Hello everyone, myself Mr.G.Paul Davidson, Assistant Professor, Department of Computer Applications, Bishop Heber College, Trichy. Now we are going to discuss on the fundamentals of deep learning. In that, the topics which we are going to discuss are machine translation, downloading and pre-processing the dataset, encoder decoder architecture, natural language processing, sentimental analysis. So we are going to start with machine translation. Machine translation is a subfield of natural language processing to focus on translating or speech from one language to another. The ultimate goal of machine translation is to produce accurate and fluent, meaningful data translations without the need of human intervention. So here we are going to discuss on the following topics in machine translation. The first one is tokenization, encoder decoder architecture, transformer. Let us take an example of machine translation with transformer. Take for example, we want to translate the sentence, hello, how are you, from English to French using transformer model. So we have to go on using the following steps to convert the entire sentence to another language. The first one is tokenization. So here we are importing there is text, the sentence, then it is tokenized into individual words or subwords. For example, there is hello, which has been there is given as an individual words using double quotes, and each in tokenization, each words or that is sentence or letter is been divided using a comma. So this is how the sentence is been tokenized. Then next encoder. After the tokenization steps, the text is been passed to the encoder, where the contextual representations of each token has been processed here. Then the decoder starts its process using the context vector methodology to convert the tokenized words to convert or to translate the tokenized words into another language as given here. And finally, the output, that is the model, produces the translation, that is which is been given here as a target language. Now we are moving on into the next topic, that is downloading and pre-processing the data sets, which is it is an essential step in building machine learning models, including for machine translation. So downloading a data set, we can obtain data sets for machine translations using various sources. Then the next step is pre-processing the data set. To perform this task, we have to follow the steps which is given here. The first one is tokenization, that is breaking the text into words, subwords, or characters. Then cleaning, that is removing special characters, redundant spaces, etc. Then lower casting, that is converting all that is text to lowercase to maintain consistency. Removing rare words. Some words may not appear often, which has to be removed or replaced with special tokens. Then padding, to make all sentence in a batch of the same length. Then truncation, that is cutting long sequences to a maximum length. Tokenization. Tokenization is a important steps in natural language processing, which involves breaking down a sequence of text into smaller units known as tokens. These tokens can be words, phrases, characters, depending on the levels of tokenization used. Types of tokenization. There are four major types of tokenization used here. We will discuss it one by one now. The first one, word tokenization. This approach splits the text into individual words. For example, we are giving an input in the form of text, as natural language processing is fascinating. The output will be like this. There is each individual word in a sentence will be separated by using comma, using semicolon. This is how word tokenization is been used for dealing with text. This word tokenization is also used to handle tasks like text classification, sentiment analysis, and machine translation. The second one is sentence tokenization. In sentence tokenization, the text is split into sentences. For example, there is the sentence is given like this, the form of input. That is, I love coding, full stop. It's fun. The output is, that is, the word which ends with full stop will be splitted into first token and the remaining text into the final token. So this is how sentence tokenization is used to split text into sentence. The third one is character tokenization. This involves splitting text into individual characters. It is useful in tasks like spelling correction, language modeling, and text generation. The example is given here. Here I have given a word hello as input, and the final output will be like this. There is each individual, there is word, each individual, there is letter is been converted into tokens. The fourth one is subword tokenization. It is used in methods like byte pair encoding or word piece, split words into smaller meaningful components. This is particularly helpful for handling rare words. The example is given here where the input is given as unhappiness. The output is, there is, it splits the un as an, there is first token and happiness as the second next token, or subwords segments like unhappiness. So this is how the particular word in a sentence is been converted into subwords or word pieces. Tokenization has several applications in NLP. There is, we will discuss one by one now. The first one is text pre-processing. Before performing any kind of analysis or learning task, tokenization helps clean and prepare the text. Next is vectorization. Once text is tokenized, it can be represented as numerical vectors using techniques like TF-IDF, word embeddings, word to vector, or glove, etc. Next one is parts of speech tagging. Tokenization helps break the sentence down to words which are then tagged with their respective parts of speech. Such as nouns, verbs, adjectives, etc. Next one is named entity recognition. Here, the tokenization is used to split the text into tokens that can be analyzed for named entities, like take for example names of people, places, organization, etc. Next one is text generation. For generating models like GPT, tokens are breakdown into manageable model for training and interference. So now we are going to look into the topic vocabulary, which is a part of NLP. A vocabulary refers to the collection of all unique words in a data set that the model can recognize. A good vocabulary plays a vital role in tasks like machine translation, text classifications, and language modeling. Creating and managing a vocabulary is an important pre-processing step. Here, we look at different options for loading datasets from files or various external sources using some common pre-processing steps. In the first step, the dataset format, that is, the dataset which is derived from the external sources, will be, that is, in various formats like CSV or TSV files. Then the second step, reading the dataset from files. That is reading from text files or reading from CSV or TSV files. The third step is the pre-processing step. That is pre-processing the data set. Then after pre-processing, in step number 4, the tokenization process has been carried out. And finally, in the final step, we are splitting the data set. Now we are moving on to the next topic, that is encoder decoder architecture. It is a widely used approach in machine translation and other sequence tasks in natural language processing. This architecture is particularly effective for transforming an input into an output sequence while maintaining the schematic meaning of original sentence. The encoder-decoder model consisting of two main components. The first component is encoder, where it processes the input sequence and compress it into a fixed length context vector. Then the next one, decoder, perform its operation, where it takes this context vector and generates the output. In, in this context of machine translation, the input sequence would be the sentence in the source language and the output would be the sentence in the target language. So now let us discuss the topic little bit elaborated. First, we will discuss on encoder. It is typically a recurrent neural network such as long short-term memory are gated recurrence units. These are different. The RNN, LSTM, and GRU are different classes which belongs to artificial neural networks. Here, the encoder processes the input sequence word by word and encodes each word into a fixed size vector. The final hidden state of encoder represents the compressed version of the entire sequence. Take for example, if the input sequence is I love machine learning, the encoder would process each word and updates its state at each time until the last word is generated. The context vector representing the entire sequence. Next comes the decoder. It is another recurrence neural network that generates the output sequence at a time. Here, the decoder is con- conditioned on the encoder's final hidden state or context vector. This context vector serves as a summary of input sentence and is used by the decoder to generate a corresponding sentence in the target language. At each step, the decoder produces the next word in the sequence, which is fed back into the decoder as input for generating the next word. This process is known as auto-regression. Example, the given context vector from encoder. Take for example, the sentence, I love machine learning. The decoder will generate the word into J AMI L a percentage automaque, which is the translation in French. So, by using this auto regression method, we can able to there is convert or decode the text, the target text into another language. Next, we are moving on to into the another main topic in unit number 3. There is natural language processing. It is a field of artificial intelligence which focus on enabling computers to understand and generate human language. It combines linguistic and computer science to create systems that can process and understand natural language, which is inherently complex and ambiguous. The goals of NLP is to understand the meaning, language generation, and finally, interaction with humans. The NLP plays a vital role in various applications, and some of them are listed here. We'll discuss it one by one. Chatbots and virtual assistants. NLP is used in systems like Alexa, Siri, and Google Assistant to process voice commands, understand user intent, and generate natural responses. Next is machine translation. Here, NLP model like Google Translate, which rely on machine translation models to convert text from one language to another. Next one is text analysis. It is commonly used in business applications for analyzing customer reviews, social media sentiment, or feedback to understand the trends and opinions of customers. Next is search engines. NLP plays a vital role in search engine algorithm by interpreting queries, ranking results, and providing meaningful answers. Next is speech recognition and synthesis. NLP is used in converting spoken language into text, that is speech into text, and generate them from text to speech. Next one is document summarization. NLP is used to automatically generate summaries of long document, helping professionals to quickly digest the information. The next one is healthcare. NLP is also used in healthcare sector to analyze medical records, patients' reports, and generate summaries. Next, we will move on into the another main topic in unit number 3, that is sentiment analysis. Sentiment analysis is one of the widely used applications in NLP, aiming to classify the emotional tone behind a body of a text. Here, the goal is to determine whether the given text expression is positive, negative, or neutral. It is important in various fields, including social media monitoring, customer feedback analysis, and product review classifications. The both RNN and CNN are used in sentiment analysis in various ways. First, we will discuss the role of RNN in sentiment analysis. RNN is a deep learning algorithm to train data set and class of neural networks designed to handle sequential data such as text, speech, or time series data. Sentiment analysis often requires understanding the order of words and how the sentence evolves through a sentence, making RNN well suited for this task. How RNN works in sentiment analysis. It processes one word at a time while maintaining a hidden state that captures information from previous words in a sequence. This makes RNN ideal to task for sentiment analysis where the text is often dependent on the sequence of words. And finally, we'll discuss the role of CNN in sentiment analysis. CNN is another deep learning algorithm that uses filter to analyze dataset, typically used in image processing. CNN focus on extracting features from data through conventional layer, making them highly effective for recognizing patterns with text, such as word engrams. CNN are particularly good at identifying important phrases or patterns in the text that signal sentiment without needing to explicitly process the sequence of words over time, as RNN do. Let us now discuss elaborately on how CNN perform its role in sentiment analysis. These are the different steps. We'll discuss one by one. First one is embedding layer. Here the text is passed through an embedding layer where each word is converted into a dense vector. So there are different types of embeddings, word embeddings used, and they are mentioned here. For example, word to vector, glove, or fast text, etc. Next one is conventional layer. It is applied to the word embeddings, looking for features like word combinations. There are two sub-layers in conventional layer. One is pooling layer. So after this conventional layer perform its task, then the text is moved into the pooling layer where there is the main objective is to reduce the complexity. And finally, fully connected layer. Here there is the final classification is performed on the text, that is whether the given text is positive, negative, or neutral. Thank you for your patient listening.